about arc length. So arc length is a portion of circumference. Here's our formula. We have S, which is a representation for arc length, is equal to R times theta, where R is a representation of a radius and theta is an angle. Now, this week we learned that angles can be represented in two ways. I want you to concentrate on radians, so you may have to convert. When you convert, you could go from degrees to radians or degrees minutes seconds to degrees to radians. So I want us to find the length of an intercepted arc with a central angle of 240 degrees and a radius of 4 inches. So a central angle and the measure of the angle are going to be the same thing. For me, words are hard in terms of math, especially with problems like these, so I'm going to draw a picture. So in my picture, I have a circle with a radius of 4 inches and a degree measure of 240 degrees, as you see here. Now the issue is I'm in degrees and I need to be in radians. So I'm going to take the 240 and multiply it by pi over 180. Here's where a calculator is going to come in handy because I'm going to do 240 divided by 180, which gives me 4 over 3. Don't forget, though, you do need to insert the pi back into your equation. Now I can take that 4 pi over 3 and insert it into my arc length equation. So 4 times 4 pi over 3. Let's round to the nearest hundredth. So that's going to give me 16.76 inches. Let's try again. Find the perimeter of a 60-degree slice of a large pizza. I'm going to say that the pizza is actually 14 inches in diameter. I will fix that in my notes in a second. Okay? So I know this is a weird way of saying a pizza slice, but just go with it. It's a calculus problem. Now in calculus, one of the hardest things that you're going to have to do is you're going to have to read what the question is asking you to find. Most of the time students know what to do, but sometimes you give me the wrong portion of the answer. Just like in number 1, I'm going to draw myself a picture. So with the perimeter, I want the distance around. So I'm going to start off by finding that arc length piece. So I'm going to take my 60 degrees and convert it to radians. So 60 times pi over 180 is going to give me 1/3 pi. But the 1, really not necessary, so I'm going to make it pi over 3. Then I'm going to insert that pi over 3 into the arc length formula. So I have S is equal to 7 times pi over 3, which is going to give me 7 pi over 3, or 7.3. Problem is that's not the whole perimeter. That's only the arc. I need those 2 straight edges that are part of the pizza. Those 2 straight edges happen to be radians. There's 2 7s, and those 2 7s give me 14. So I'm going to add the 14 to the 7.3. So I'm going to get 21.3 inches. Okay, part 2 of our notes, we have conversions. This is going to feel a little bit like science because I'm going to make you go from one big unit to another. So we're going to have a truck tire with a 36-inch diameter that travels at 360 revolutions per minute. I want to know how fast that truck is traveling in normal speak or miles per hour. So here are some conversions that you need to have memorized. You may not have them yet, but we need to get there. There's 60 minutes in an hour, there's 12 inches in a foot, there's 5,280 feet in a mile, 1 radius per radian. That one's going to be a little strange because the radius is going to change per problem. So stay tuned for that one. 1 revolution, that one's 1 full circle or 2 pi radians. All right, so now when we go to do this, we are going to have a series of fractions. The first one is one that's given to us, 630 revolutions per 1 minute. I like to start with the time measurement. Just for me, it's the easier one, but it doesn't matter which one you start with. So I'm going to start with minutes and ask myself, how do minutes relate to hours? Well, there's 60 minutes per 1 hour, and then I also need those minutes to cancel. So I'm going to put my minutes in the numerator and my hour in the denominator. So now I have minutes in numerator and denominator, so they cancel out. I'm going to cross them out them in red to let them know. So now I'm at hour, and that's where I want to be. So now I've got to go back to those revolutions. I can refer back to those conversions that I gave you up there in blue. So 1 revolution is going to correspond to 2 pi radians. But now we've got to make sure we be careful about who goes in the numerator and who goes in the denominator. Since revolutions is currently in the numerator, we want it to go in the denominator. So I have 2 pi radians per revolutions. Now revolution cancels out. Now let's consider radians. Radians are going to correlate to radius. Okay, radius is currently in the radian is currently in the numerator, so now I need it to go to the denominator. The radius in this problem is 18 inches. Be careful, I gave you the diameter, so you have to cut it in half. So now my radians cancel, and I have inches. So now I'm gonna do inches to foot. So I've got 1 foot per 12 inches. Inches cancel. Then I've got 5,280 feet per 1 mile. My feet cancel, and I'm left with the measurement that I need. Now I'm gonna rewrite all of that with just the numbers. The units of measure are just meant so we can have a visual representation of how things cancel. So I am going to take 630, 60, 2 pi, 18, 1, and 1. Multiply that together. So notice that I'm just worrying about the numerator. That's going to give you a really, really long number. Now I'm going to consider the denominator. I've got 4 ones, 12, and 5,280. When I multiply those together, I get 63,360. Now we're going to divide those to get our final answer. Let's round this one to the nearest tenth. If you do this correctly, you get 67.5 miles per hour.